Okay, so in this next video, what we are going to be doing is just adding or subtracting fractions that have unlike denominators, or writing two terms as one in preparation for verifying your trig identities. So let's take a look at this first fraction. I can't subtract them because they don't have like denominators. So what we have to think about is the jealous denominator. Denominators want what the other denominators have. So if we look at this first denominator, it has sine squared b, and the second one has sine of, sorry, that's beta, sine squared beta, and that's a sine of beta. And so your least common denominator is going to be sine squared beta. This one has two sine of betas, and that one only has one. So what you'll do is you'll multiply and change your fraction. So that's a multiplication of sine of beta over sine of beta. Or we could write it like that. I think that'll be my preference. And then we can simplify. Now they have the same denominator. So they have the denominator of sine squared beta. And in your numerator, let's just simplify as we write. Rewrite. That's 1 minus cosine beta sine beta. And there you go. Okay, for problem B, we want to combine these into one term. So first we'll create a fraction, and then we'll go with the jealous denominator. This one already has the invisible one, so this one just wants what this one has. So we're going to do times cosine theta over cosine theta. So that we're multiplying this term times 1, but we're giving them the same denominator. Then we can move forward where they have the same denominator, and then simplify as we multiply across, or I'm sorry, simplify and multiply these two terms. And we'll extend that out, and there you go. All right, last one here is a little more complicated because they're complex fractions that you're trying to add. So my suggestion here is to simplify each complex fraction first and then go through the process of adding them. So the first thing I'm going to do is just work down here and simplify this down to a single term, simplify this down to a single term, and then I'll work the problem as I've done these others. So with this problem here, you got to look for the longer fraction bar that's in line with your addition or subtraction sign so that you can determine which part of the fraction is your numerator versus your denominator. Okay, so numerator, denominator. All right, so make sure you're practicing determining that. Okay, so I'm going to rewrite this here with a fraction in the numerator and a fraction in the denominator. So we're going to write 1 over 1 over cosine theta over sine of theta. Okay, and then remember our jealous denominators. I've taught you this before, and in fact, if you haven't watched the video on simplifying complex fractions, you should go back and watch that first. Now that you're almost done, here we go. This denominator here wants what this denominator has. This one has a 1, it's just invisible. So we're going to multiply the top, or top of our complex fraction, times sine of theta over sine of theta. Now they have the same denominator. We can simplify them. And so our new fraction, this fraction simplified, is sine of theta, which is the answer to that right there, over cosine of theta. Okay, and there's other ways you could go about finding that, but let's just go with that for now. Now let's come back and work on this part. So I'm going to write them both as fractions. So 1 over cosine theta over cosine theta over 1. Jealous denominators. This denominator wants what this denominator has, so times cosine theta over cosine theta. And then you can simplify your complex fraction into 1 over cosine theta. So there's, you have it, 1 over cosine theta. And well, that worked out really nicely because the denominators are the same, so you can just continue to combine two terms into one. Sine of theta plus 1 over cosine theta. I do want to talk about this in another way, just in case this would be something you'd rather do. So let's take a look at 1 over cosine theta over sine theta. What that says is 1 divided by cosine theta over sine theta. And if you go back to when you learned your rules for multiplying or dividing fractions, you would just keep this the same, change that to multiplication and multiply by the reciprocal, and then you'd multiply. So we have sine of theta over cosine theta, which is what when we did this, that's what we got. So if you would like to go through this thought process instead to simplify your complex fractions, that's a good method for doing that when the complex fractions aren't loaded with addition and subtraction embedded in the fraction. Okay, there you go.